Okay. How how many are you actually? You're supposed to be how many students are attending the class?
I think there are seven.
Ah, you are just seven of you.
Yes, seven or six, I think.
Okay, I thought that there are more. Okay, so that means we can start. Okay, seven or six. So you just have two absent. It's good. So let me open it a little bit. So can you see me?
Yes, we can see you.
Okay, this is for you just to know to see my face, to know who I am. So you can see me. So my name is Boris. So hi to everyone. So
Hello. Hello.
we are going to work for a whole week. We are going to discuss a little bit about cloud computing and cloud infrastructure. I mean, we are going to talk about infrastructure that is needed to implement cloud services. You are going to talk a little bit about cloud services. You are going to do some lab work on Amazon and also on some technologies that are used in cloud computing. So I'm a assistant professor in a university in France. The university name is INP, Institut National Polytechnique de Toulouse. So it's a engineer school in Toulouse here. Okay.
I have a question, small
Yes.
question. So, do we use Amazon Cloud or Google Cloud?
Amazon Cloud. Amazon Cloud.
Okay.
So do you people prefer Google Cloud?
A tiny bit about Amazon Cloud, yes.
Ah, you prefer Google Cloud to Amazon Cloud, if I understand well. Okay, but I'm sorry for you, but we are going to use Amazon because I have an account there, and you people are going to use my account. So, are you familiar with cloud computing, or is it new for all of you?
Not everyone.
For example, you just answered. Are you using cloud computing, cloud solution in your company? Um,
No, we just use it in a small project, so not for a company.
in a school project or something like that.
Uh, it's an application on Android, I think.
Ah, application on Android. And what did you do in the cloud? Why did you use the cloud to do what? You use the cloud for which purpose?
It's a problem about it's like Airbnb but for students. So it's for querying the database.
Okay. Okay, so you use cloud services for as a data storage. You use it for data storage, if I understand well.
Yes, a bit like that.
Okay, good. So, do any one of you have any experience with cloud computing? This is we should interact. That means you should discuss. It's not just that you are going to cut your mic and I will talk for 4 hours and that's it. No, we interact. That means I say something, you react, you ask me questions, I ask you questions. I prefer the class to be like that, not just you having your microphone shut down and just listening to me because it's better for us to interact. So when I ask you a question, you should speak. Don't be afraid. So have any one of you have any other experience with cloud computing in a school context or in a company context?
You should speak because you are doing the same thing now.
So no one. Okay. Okay. So I heard something. I used to write some API in AWS Lambda. Okay, so you have some one of you who already wrote some API for AWS. I use ACD platform AWS. Good. Okay, good. You have some experience. That means for those who already used I also familiar with SA2, DynamoDB. Perfect. Good. That means you already have a lot of knowledge about cloud computing. It's very good. It's very good. So okay. So we are going to do some of the we are going to use some of the services that you list, so, that one some of you people already use, so that everyone will know about the technology, and we are going to talk about some concepts too. Very good. If some of you are familiar with cloud computing. So today we are going to start with the introduction class. So we are going to talk about issue of cloud computing, define some concepts, talk about the different roles you have in cloud computing. We are going to talk about data centers. What is the difference between a cluster and what is the difference between cloud computing and grid computing? We are going to give some definitions that are related to cloud computing. So today we are just going to do an introduction, and at the end of the class, you are going to do a lab work, and the lab work will be on Amazon. We are going to use the EC2 services on Amazon. So this is the first introduction we are going to have with cloud computing. So on Amazon, you are going to use the EC2 services, which is the infrastructure services that is provided by Amazon. You are going to create virtual machine. You are going to configure this virtual machine, define the security rules that we want to use to this virtual machine. That means define the access, the port that should be open to get access to this virtual machine, and use some scaling services that is also available on Amazon. So to start, we are going to start by the introduction. So do you have any question or suggestion on what I just said?
Do we need to use Ubuntu or Windows is okay?
Oh, for the class, actually, to do the work on Amazon, you don't need you don't need any special operating system. You can use Ubuntu or Windows. And for the rest of the lab work, because you are going to work with some virtualization technology, and so I have a we will talk about it later, but I have a server here, and you will just have to do a SSH. That means you have to remotely connect to my server and do your lab work. So you can do the class with any operating system. You will have no problem. You can use a Windows operating system or a Linux operating system, no problem. Even
Okay.
a MacBook, you can use it. So I will make sure that you connect remotely on my servers here and do the lab work. So so
Teacher,
okay, yes,
yes, I have a question. So, because some our member need to we have to go come back home from the office. So we have a short break about 30 minutes in the middle of the session for
yes, of
them
course.
to go home.
Of
Okay,
course,
thank you.
we have a break. We just it relax. Eh? I know that you people you are from evening class. You are just up. You are just from the work. I know. So this is why most of the time I will give you something like 15. I will start the class 15 minutes after the time, so that you people can connect and we will have a break, because I know that you are just out from the work. That means you are kind of tired, and it's not the first time I am doing the class in Vietnam, so I know the context. So don't worry about it. I will consider
Okay.
we consider it. So it's a relaxed class. It's not too difficult. It's more like history.
Yeah.
So
Okay. Thank you.
what I'm expecting for you is for you to react to ask question. If you don't understand something, you say, sir, we didn't understand this. Can you explain this better? And it should be an interaction class so that it will not be too heavy for you, because it's not so difficult. It's cloud computing. Cloud computing is very easy. Everything is everything is made in cloud to be very easy. So so today we start with the introduction to cloud computing. Can you see my slide? Is it okay?
Yes.
Okay,
Yes, we
perfect.
can.
Okay, so the objectives of this class, we build to do a introduction to cloud computing. We are going to talk a little bit about the story of cloud computing with Amazon. After that, we will give some definitions, definition of major concepts, and we have some example of cloud providers because there are many of them: Amazon, Google, Hackscale, for the most famous ones, even Microsoft Azure. The cloud computing started to be the idea of cloud computing started in the 2000 years with Amazon. So do you all of you know Amazon, I suppose. So Amazon is basically Amazon was a selling website, if I can say it like that. So Amazon was built in order to allow to sell goods to individuals. So in order to put their website the website in place, they needed some infrastructure to be able to run the application because they wanted to sell goods to individuals. It's an e-commerce website. Yes, that's a good word. So what they usually do is that they buy servers, and on this server they host the application that allow people to purchase goods from them. So what they notice is that most of their servers are not used fully because not every time in a day um, people are connected on their website to buy goods or to command things. So they observe that their hardware or their server is not fully used. So what they decided to do around 2002, they decided to rent part of their infrastructure to people outside from the organization. So they rent to external user a part of their computing facility during the period of low use. For example, if you know that during night people don't usually buy things on your website, that means during the night your resources is not used. Your hardware resources, that means your server, are not used. So they say, okay, why not just during this period of time rent our facilities, our computing facilities to external user in such a way that they will pay for us for it, and this will help us reduce the cost of ownership of the hardware. Because when you own a hardware, when you own servers, there are many costs that come along with that, because you have to pay for engineers that have to maintain this hardware, you have to pay for employees, you have to pay for software, you have to pay for license. So they say, okay, why not just rent our computing facility to external user in such a way that we can reduce the cost of ownership. So this is how they started, they think about it, and they launched the Amazon Web Services. So basically, it was initially for data storage. After they move it to computing, they say, okay, let us use our servers to be able to let us allow some external user to use our resources, and we will use the money from that to reduce the cost of owning these resources. So an analogy can be seen with a car. For example, when you own a car, I don't know in Vietnam, but in France, for example, when you own a car, there are many any other um, expenses that you have to do that are related to the cars. So when you own a car, for example, you have to pay for insurance, because having a car, that means you have to insure your car, and this every month you have to pay an amount of money to a insurance company in case of accident, in case of a, of a problem on the car. The insurance will take it in charge. So when you have a car, you have to pay for it. But the thing is that when you have a car, most of the time, don't use the car every time, because you use the car, for example, every morning when you want to go to work and evening when you are back from the work. That's it. Maybe during the weekend. But when you are at work, when you are working, you are not using the car. That means you are paying for something for a full month, the insurance you are paying for a full month. But you are just using the car for a very, very few period of time during the week. So you are not using fully your resources, you are not using fully your cars. So what you do is that you can rely on other services to, you can decide to do what, to rent your car to people during the time you are not using your car. So that means you can say, okay, during the work, if I'm not using my car, what I can do is that I will allow someone, some guy, to come and rent my car and use it during the period where I'm in the office. And when he's going to use my car, this guy is going to use my car, he's going to pay me. And this money I can use it to pay my insurance and reduce the cost of ownership of my car. So the same principle can be applied in many contexts. So this is why in France you have many websites like BlaBlaCar that allow you to rent something like a car or to share your car with other people in order to reduce the cost of ownership of this car. So generally, you have an underused resources that can be a computer, a car, and you rent these resources to external guard, to external user on demand. That means when I'm not using it, I rent it to someone, and the guy uses it, he pays me, and this allows me to reduce the cost of ownership. So basically, this is the basic idea behind cloud computing. Rent my resources when I'm not using it. By doing so, it increases the utilization rate. Therefore, it increases also its rentability. So the main principles of cloud in cloud computing is mutualization. Hello, are you still getting me?
Yes, we're still hearing.
Okay, good. So
Yes.
the main idea behind cloud computing is mutualization. That means you use a set of limited resources and share it amongst many different users. So you have a resource that is not used fully by you. You decide, okay, let me just mutualize it. That means share it amongst many different users. You share an equipment. And the good thing about it is that your resources will be fully used, because the fact that you are sharing your resources among many users, that means your resource will be better used. The advantage for the user, you will see it later, is that because he's not owning the resources, he doesn't have to pay for the cost of owning a resource and just use the resource when he needs it. He needs it. So, for example, imagine for the example of the car, I'm not the one owning the car. I don't have a car. But when I need a car, I just go and see a guy. I say, okay, please rent me your car. He rent me his car. I just pay for the time where I'm using the car. And after that, I give him back the car. So I just pay for when I'm using the car. This is a benefit of mutualization also, because the fact that because we mutualize the thing, I have more flexibility on allocating and using the resources. We are going to discuss more about it. So the advantage of mutualization is what? It reduces the cost, because many people use the same hardware. That means generally, if we are 10 of you using the same thing, it reduces the cost for individuals. And also it reduces the wasting, because your resources is fully used. For example, when you're talking about wasting, you are going to see later, you are going to see, for example, an energy. When you start, for example, a server consumes an amount of energy. Even you have a minimum energy that is needed to start to have a server running. Even if the server is not running an application, even if there's nothing running on it, but you have a minimum energy that is consumed, and this minimum energy is not small, it's a huge amount of energy needed to start the server. So rather than having this server running without any application, without many applications running on it, you better use it for many clients so that you will not waste your energy. You will not provide useless energy to the server running nothing. So by mutualizing, you reduce the wasting. You also push the limit. That means you use fully your hardware. So this principle of mutualization, you have it everywhere. You have it in bus. Other than every people having its own car, you have a bus that is shared between many people, and that is mutualization. By having a bus, it reduces the cost of transport. So when you apply this mutualization principle, you have cloud computing. You have a share, you have data centers that host servers, and these servers are shared amongst many clients. And to allow this to be possible, you have to do what we call externalization. You have to externalize. So because we have data center that host server and application will be run on these servers, you as a client, you should accept to externalize your resources. That means you should accept to move your infrastructure or your application on this data center and have a remote access to this data center in order to use your application. So this brings us to the definition of externalization and cloud computing. So this is a general overview of what is a representation of cloud computing. So when you talk about externalization, as I just said, on the left, yeah, you have companies and you have individuals. Companies can be big companies, small companies, startups, and you have individuals that can be used. So when you decide to externalize, it's so that you say, okay, now I will not have my application running on a data center that is in my company or at my place, but I will send it to a remote data center that is managed by a cloud provider, and I will just have external access to this software. And this external access is done through a network, which can be internet. So the guy who manages the data center here, he hosts my application, he managed the infrastructure, and I just have a remote access. So in order to do the mutualization thing, I need to accept to externalize my resources. I need to accept externalization. Hello?
Yes.
Yes.
Is it okay for everyone?
Yeah.
Yes.
Okay. So with this in mind, knowing that, okay, first thing, principle of cloud is mutualization. Share a hardware resources amongst many clients. For this client to be able to share these resources, they must accept to do what we call externalization, accept to deport their software into a data center that is managed by a third party. So basically, the first services, cloud services that were proposed by Amazon was Amazon Elastic Compute Cloud. So this is Amazon services that allow you to reserve a computing capacity. That means you say, okay, I want some amount of CPUs, I want some amount of memory, and this Amazon EC2, which is one of the first services that were provided by Amazon, allow you to reserve a computing capacity. And this reservation of computing capacity is done through what we call virtual machines. We are going to talk about virtual machine later. So what was happening is that, and what is still happening is that your client connect to a portal, and on this portal, he kind of reserve a computing capacity on Amazon data center. And this reservation is at as he wishes. That means anytime, any amount of resources. And the client can use this computing capacity to run his application. So the client has the illusion that he has a dedicated server running his application. So now, for the client, rather than having a data center in my company or at my home, what I do is now I externalize this into a specialized data center, and I just connect to a portal and deploy my application on this data center and use it remotely through a network. So having all of this, we can give a definition of cloud computing. So cloud computing can be defined like this. It's a set of resources, application services, which is executed in a distributed environment in a data center, and that is accessible through a web standard protocol, which globally provide a service with the following characteristic. You have the pay-as-you-go, illusion of infinity of resources, abstraction of the hardware infrastructure, and mutualization between many users. Hello?
We are still here.
Okay, good.
Yes, we still here.
So when you have all of this, you say, okay, so what is cloud? So cloud, you have resources, you have application, you have services that are executed in a distributed environment. So these are elements that are executed a in data centers, in hosted centers, and these resources, application services are accessible through a networking. And this set of elements should should follow some characteristic. You have the pay as you go. Pay as you go is what you pay for what you use. That means if I'm using, I'm paying. If I'm not using, I'm not paying. You get it? So you have
Yes.
the illusion of infinity of resources, scalability. So we're going to discuss, but to say a word about, we are going to give more details about this, but to say a word about it is that actually when you are in a cloud, when you are using a cloud services, you don't have an idea of the exact amount of resources that are available in the data center. You always have the illusion that if I need more resources, if I need more compute, if I need more memory, if I need more, I can have it. Because you have this illusion that everything is infinite, everything is too much. That's cloud computing. You have illusion of infinity of resources. You have the abstraction of the hardware infrastructure. You, as a cloud user, most of the time you don't have an exact knowledge of which kind of hardware you are running. Is the cloud provider, we are going to talk about the cloud provider, which is the one who manages everything. So he knows the exact nature of the hardware running. So you, as a user, you don't have a clear knowledge of the hardware running below your application. And you have the last characteristic, which is mutualization. You have many users that is using the same hardware, the same resources. Any question?
Not yet.
Okay. So it says easy is clearly smooth. So most of the time, there are many questions about what is the difference between cloud computing and grid. Have you ever heard of grid?
So it's a group of computer in the same network and in the same physical location, maybe.
Mm. So grid, if I give a definition of grid, is a group of compute nodes. It can be computer or something else because you can do grid with a smartphone. You can do it with anything. I will just call it compute nodes. So that a node that can carry out computation. So that's it. And a grid is just a grid is a group of compute nodes that are interconnected and that can realize that can carry out um, huge computation operations. So grid generally, this is how we define grid. So before cloud computing, we had grid. That means you have many compute nodes that were connected, and on this compute node that are not that must not be on physically on the same location. On this cluster, on this compute node, you can launch computations. So people ask, why is it different from cloud computing? Because cloud computing is you have data centers, and on this data center you can kind of start execute operations. So most of the time you need to give some difference between grid and cloud. So the first thing is cloud is open to everyone. So you don't need to be expert. As I asked you at the beginning of the class, many of you already use cloud without even having to do this class. So you're already kind of a little bit familiar with cloud. If you connect to Google Doc, if you get Google Drive, you already use cloud. Today, everyone who has a computer, I think most of most of people in the herd they already be in contact with cloud computing even without knowing. So in cloud, it's open to everyone. You don't need to be expert to use it. But the grid is kind of different because, as I say to you, and grid is you have computer nodes that are interconnected. So grid in the past was devoted to researchers. So because in research, sometimes you have some complicated arithmetic operations that you have to realize, optimize something that no one understand apart from them. So grid was dedicated to researcher in order to be able to do these huge computations. This is why sometimes you have some this is why sometimes you have some note in some countries, you have some cluster in some countries, and you needed to be able to launch arithmetic or big computators on these different nodes. And grid is used to allow researchers to do this kind of operation. The other thing is that cloud is more business oriented. It's true that at the beginning, cloud was not something that allowed Amazon, for example, to be able to make benefit on it. It's just 2 or 3 years ago that Amazon started to do benefit. But cloud basically is more business oriented. So that means cloud, the idea is to make money, to make profit. That means you provide the service, you sign a service level agreement with the client, and you have the obligation as a cloud provider to provide this service. And the client has the obligation to pay you for the service he's using. So it's a business. You provide the service and they pay you for the service. So you have a billing model that is defined. But grid is not, it's a non-profit, it's for research. Okay, I want to launch it. I want to start a huge equation resolution, things like that. Oh, I launch it on the grid. So the other thing is that in cloud computing, this is important because in cloud computing, the hardware is abstracted to the users. This hardware abstraction to the user is for security, for simplicity, for security. There are many reasons why the cloud hardware infrastructure is abstracted. That means the user doesn't have a real view of the hardware. So one of the reasons is for the security, because in order to prevent attacks from malicious user, you abstract it so that if an attacker, the less he has information about your hardware, the less he can attack you. So in cloud computing, you have this abstraction of hardware, but in grid computing, due to the fact that you are in a research context, sometimes you have to do some optimization in your computation in order to be faster, something like that. In grid, you need to know the exact nature and the characteristics of your infrastructure. And this is not the case on cloud. Hello?
Yes.
Okay.
So I I remember that in France there is a grid between multiple university.
Exactly. We have, for example, I will say a grid infrastructure here called Grid 5000. This is a huge I will say these are huge compute nodes that are interconnected through a network on which researcher just start your computation on it. But it's not the same model as cloud computing. It's not for business. It's not to make money. Do you see?
Uh, I still see the slide.
Oh no, I'm just saying. Do you get it? Do you get it? So grid is mostly for research. You have this notion of compute nodes that are interconnected like cloud computing, but grid is for research. Cloud is for business. In cloud computing, you don't have a real knowledge on the hardware infrastructure, which is not the case in grid. Because in grid, you need to know your infrastructure in order to optimize your computation.
Okay. Uh,
Okay, good. So in cloud computing, you have many roles. So you have many actors. So, but there are two major actors, and the other I will call you, they are actors, but they are not so major actors. You have the cloud provider. So as I told you, in cloud computing, you have the guy. So the cloud provider is who have the infrastructure, the one who implement the services on top of the infrastructure. So at cloud provider, you have Amazon service, which is well known. You have Microsoft Azure. You have many others. You have HeartScale. You have Google, which is also a cloud provider. That you have the cloud client. So the cloud client is the one who use the cloud platform. It can be you, it can be companies, it can be anyone that uses cloud services. So these are the two major roles in the cloud. You have the provider and you have the client. And near to that, you have what we call the cloud reseller. So these are those who sells a service that rely on the cloud. So it's cloud provider most of the time what they do is they give you some basic services, and you in the middle you can build some services that are based on this cloud provider. So cloud resellers are those who build and sell services which rely on existing cloud platforms. So they are kind of users and providers. They are in between. You get it?
Yes.
Okay, so an example is imagine you implement some kind of a tool that is an example that kind of help a cloud client to choose a cloud provider. Imagine you have an application and you want to deploy this application on cloud computing. You want to externalize, and you have many providers. You don't know exactly which provider to use. A cloud reseller can be someone who provides you with the platform. Let me call it a platform that help you choose the cloud provider that is appropriate for your application. That means he can take your application and evaluate your application on various cloud providers, and depending on the metrics that is more important for you, say, okay, you should use Amazon, you should use Microsoft, you should use Google, you should use CloudWatch, you should use Hardcale or Hardcale, or I don't know. So this is a cloud reseller that he, he used he used the cloud provider services, add some added value on top of it, and resell it. So after that, you have cloud developers. So now these are computer scientists like you, which can decide, okay, now I will what I will do is implement some tools that will be used to ease the the utilization of cloud computing. So that means that are tools that facilitate the utilization of cloud computing. When I say facilitate, that means it can facilitate the deployment of cloud computing, the monitoring, the monitoring of application in cloud computing. So you have developers. So these are people that develop tools to facilitate the usage of cloud computing. So it can be you, it can be anyone. So today cloud is very is becoming very popular. So you have many people which are cloud developers. They develop tools. Say, okay, you want to deploy application on cloud. If you use our tools, this will allow you to do this. You can use our tool to help you monitor your application on cloud. You can use our tools to. So these are people who develop tools dedicated, which facilitate, which is the utilization of cloud computing. So okay, now you have the two main roles in the cloud provider, cloud client. So for each of them, let us talk a little bit about the benefit. So you as a client, why you are using the cloud? I see if some of you have already used the cloud and you already have some idea of the benefit of using cloud. So one of the main benefits is the cost reduction. This is really important, cost reduction. Because imagine you want to start you want to launch your startup. You have a nice idea of a website. Uh, you want to implement an application that allow you, I don't know, to reserve bus ticket to move from, I don't know, Hanoi to Ho Chi Minh, something like that. And you have this nice idea of application. So to put in place your application or to start your to launch everything, you need to employ people, to, 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 to employ engineers. You need to buy servers that will host your application. On this server, you need to ask to one of your engineers to deploy an application, a server application that will host your application. You need to deploy this application on your server. You need to make sure that the engineer you hired is capable of managing these servers for you, monitoring, make sure that he handles any fault. There are many costs for you to start to launch your startup. There are many things for you to make your idea of application of bus ticket to be available very quickly. But with cloud computing, you don't bother about it. You know that, okay, if I want to do my thing, I just need to implement my web application and deploy my web application on some services that is available on Amazon, on the equipment. No need to buy equipment. I know that in cloud I will have it available. There's no administration things. I don't need to hire an engineer, sign a contract, do something. The cloud provider already hire engineers that implement nice services that can be used by me to deploy my application. I don't need to care about the energy consumption of my server, talking about licenses of the application that I'm going to use. No, the cloud provider already handles everything, and I just have to connect on it and deploy my application and make it accessible to end users. So for the client, it reduces the cost of deploying, of starting my idea, of deploying my idea. It reduces a lot. It reduces the cost reduction is not just only money reduction, but also time reduction because it allows me to quickly launch my business. And for the provider, it allows it to be benefit because the provider has a set of, he has a lot of servers available in data center. And the fact that he can neutralize these resources amongst many clients, which allow you to better use his resources and make profit. And also, it allows him to better use his server and reduce and have money to pay the energy consumption due to the bill from energy consumption due to his server. Because as I told you, when you have a machine, if you start your machine, for example, you have a laptop, you start your laptop and your laptop is running zero application, you still pay your laptop will still consume an amount of energy that is not negligible. And the difference between when your laptop is idle, that means not running any application, and when your laptop is fully used, the difference is not so huge. So having servers that are not used is costing having servers that are not used is costing a lot of energy. It's consuming a lot of energy. Rather than having servers that are not used, you better use them, let other people use them so that they will pay you, and this will help you pay your bill, your energy bill. So apart from the cost reduction, you also have the pay as you go benefits for the client. So as I told you, one of the characteristics of cloud computing is the pay as you go. That means when you use the cloud, you pay. When you don't use it, you don't pay. So with pay as you go, you have the flexibility and the easy to use. So in cloud computing, the allocation and the disallocation is very fast and on demand. So today, if you want to reserve, for those who already use EC2 or DynamoDB, anything, any services, you just connect and you start everything. You can allocate, you can disallocate as you want. Nothing, you don't have to do anything. There's no administrative procedure. To create an Amazon account is very easy. 10 minutes, that's done. And once you have created your account, you can do whatever you want. Allocate resources, disallocate resources as you want. Their services is accessible from everywhere. You just need the internet connection. Once you have an internet connection, you can get access to your console, to your workspace, and you can do whatever you want. So finally, the total cost of ownership is less important. So to launch a business, you need less investment. You need less money to start a, to launch your startup. So the total cost of ownership is reduced a lot due to cloud computing. Less staff. You don't need to hire an engineer to manage your infrastructure. You don't need to pay for licenses. Everything is already included in the cloud prices, the cloud price. So with the cloud computing, the billing is very interesting for the client. So you pay according to the usage. I use, I pay, I don't use, I pay. This is the pay as you go. This is the concept between pay as you go. And the payment can be monthly or annually. It depends. For example, on Amazon is monthly. That means you use it at the end of the month, you take the money. You can define the payment annually. It depends now on the size of your infrastructure, on the contract with the cloud provider. And what is can be also nice is that on some cloud provider, you have some discount virtual machines. That means these are free virtual machines. So these are free virtual machines that you can have, you can use freely. So these are discount VMs. So these are some major benefits for the cloud of using cloud. So today, if you have the possibility to give some advice to someone who wants to start the business, say go to the cloud, don't bother. Go to the cloud, define your infrastructure, reserve servers, deploy your thing, use services in the cloud. Because it's kind of interesting for you if you have a new idea, you want to start you want to launch a startup, it's better to go to the cloud. It's very easy, quick, fast to put in place, and be able to offer some services. So with cloud computing, you can more concentrate on your product than things around the product. So any question?
No, I think it's very clear.
Okay.
Roger.
So there are many. So there are many type of cloud. So classification with respect to property. So there are many classes of cloud. There are four main types of cloud. Let me say it like this. You have what we call community cloud. You have private cloud, you have public cloud, and you have hybrid cloud. So what is community cloud? So, what is community cloud? So community cloud is a cloud computing um, which is built. So it's a cloud. It is built by many organizations. So you have many organizations that can be many universities that say, okay, let us put together our money into a bucket and use this money to build a cloud for us, for our universities, so that each can use this cloud to do our research work or something like that. So it's a community that comes together. These are communities that come together, and together they build a cloud, and this cloud will be dedicated to the usage of this community. So this is what we call community cloud. So you have another type of cloud, which is a private cloud. So a company, when you are a big company, for example, you can decide to have your own private cloud for your internal use. For example, imagine you are a company and you are you manage very sensitive data, and you cannot allow yourself, you cannot afford to externalize it into a public cloud. So what you do is that you can implement your own private cloud with services and use it internally in your company. For example, let me say, it will not be shocking for you to know that, for example, Facebook has its own private cloud because the company is huge enough to say, okay, rather than moving everything to Amazon or to Google, we can build our own private cloud and use it to provide our own service. Because they build that Amazon will give you, you say, no, it's too much. It's better for us to have our own private cloud and we can handle it internally and make sure that our data are secure because there are many personal data that are stored by the company. So private cloud, is this a cloud that is built by a company or an institution for its internal use? And it's not accessed, it's not, this cloud is not accessed by people outside from the institution or from the company. So after that, you have the public cloud. So public cloud is Amazon, is Google, is the cloud that is available for everyone. So the cloud that can be used by personal, by individuals, or anyone can use the public cloud. You have Amazon, you have Microsoft, you have Eolas. Eolas is a French cloud provider. So this is public cloud. And near to public cloud, you have what you call hybrid cloud. So hybrid cloud is a combination of public and private cloud. So it's a mix of the two. So this is a cloud where some part of the cloud is public and some part of the cloud is private. So that means in this cloud, you have some services that are just accessible to the company, and you have some part of the cloud that can be used by external user of the company. So it's a combination of a private cloud and a public cloud. It's a mix of the two. So some services are private and other services are public. Hello?
Yes, we're still listening.
Yes.
Okay, let a minute, let me move to.
Yeah.
Let me open other slides that are better than me. Okay, let me move. So okay, yeah, you have it. I will send you this document after the class. So don't be afraid. This is you. So hybrid cloud is a combination of public and private cloud. So in this cloud, you have many types of services. There are many other because you have function as a services which are new. Actually, in cloud computing today, you have many machine learning as a services, function as a services. You have many, but now we are going to talk about the basic types of services, basic types of services, basic type of services that you have in the cloud. So these are the main service. Other services that you will see later on when you will read some documentation about cloud computing, these are just services that are based on these three main type of services, three main types of service. So when you have function as a service are just services, are different type of services that rely on this. These are just variants, if I can call it that. These new services that you see to the cloud are just variant of these services. These are the basic type of services that you have in the cloud. So you have infrastructure as a service, you have platform as a service, and you have software as a service, not service as a service. This is an error. It's a SaaS. So infrastructure as a service is the short word for it is IaaS. Platform as a service, the short word is PaaS, and software as a service, the short word is SaaS. So in a IaaS, the cloud providers give access to a computing facilities to the users. So for example, Amazon EC2 is the IaaS services provided by Amazon. That means you reserve computing capacity. So when you connect to the cloud provider, you have access to a computing capacity. That means you have access to a virtual machine. You have access to a server. And on top of this infrastructure, you can install whatever you want. You can install any software you want. You install the software stack needed for you to make your service to be available to the end user. So you reserve a computing capacity, computing facilities, a storage and computing facility. This is infrastructure as a service. That means you buy for an infrastructure. And yet to that, you have what we call the platform as a service. So with the platform as a service, what happens is that the cloud providers gives you access to a platform, and on top of this platform, you can deploy or execute your application. So in a IaaS, you just have access to an infrastructure. In a platform as a service, the cloud provider gives you a platform. That means can be a web application server like Tomcat or Apache. And on top of this platform, you can deploy your application and execute the application. So with a PaaS, you have access to a platform. With a IaaS, you have access to an infrastructure, to a computing capacity. With a SaaS, you have a direct access to a software. So for example, when you use a Google Doc, you just connect and use the application Google Doc. You have a direct access to the application and you don't need to configure anything. You don't need to deploy anything. You just use the Google Doc thing. So this is not as a software as a service. That means a software is directly provided to the end user. So as you can see on the text that is below, this is kind of a little bit of these are notes for this thing. So with a SaaS allow user to run online application. So software, it allow you to run online application. With a PaaS, you deploy application and your application is executed on a platform that is provided by the cloud provider. In the case of a IaaS, you have an infrastructure, and on this infrastructure, you have to install everything that is needed to run your application. So from IaaS to SaaS, it's just a story of responsibility transfer from the client to the provider. So let me give you some. So this is an image representing the responsibility, as I just said. So the first column is on premise. That means you are not on the cloud. I mean, you own your own server, and on top of that server, you handle everything, you manage everything. So if this is the case, you have to have a network interface for the networking. That means network card that can be infinite band, fast Ethernet. You need the storage devices, all of this in the server. And on these servers, you should install a virtualization technology. It's not a must, but you can do it. Let us say you install it. You have an operating system that you should install. And on top of this operating system, you should install some kind of a middleware, a server, application server. That can be Tomcat, that can be Apache, and that can be engines, Apache, yes, that can be Apache. And on top of this middleware, you should install a runtime. That can be Java, that can be Python. You have the runtime. And on top of this runtime, you have the data of the application and you have the application. So if you are on your own server, you have to handle everything from the hardware infrastructure to the software stack, starting from the operating system to the application. So you have it here. Oh, sorry. Do you get it?
Yes.
Okay. But when you move to YAS, so you say, okay, let me go and move and use the infrastructure as a service of Amazon. So what happened is that Amazon handled the hardware. So this part, this blue light, let me call it blue light part, from virtualization to networking, is handled by the cloud provider. So in the case of infrastructure as a service, the cloud provider handle the servers and even the virtualization technology. It just gives you access to a virtual machine. And in this virtual machine, you have the control over the operating system. That means you decide which operating system should be installed on the hardware. You decide on which middleware. You are the one who installed the middleware, the Apache, the Tomcat server. You are the one who installed the runtime, Java, Python. You are the one who installed the data for your application. You are the one who installed the application. So when you are using the YAS, the cloud provider has a limited control onto the level of virtualization, and you as a client, you manage everything up. You manage the operating system, the middleware, the runtime, the data, and the application. In the case you are using a PaaS, a platform as a service, the cloud provider manages everything from the hardware to the runtime. That means he installed the middleware, the operating system, the runtime. Everything is managed by the cloud provider, and you just come with your data and your application to run your application. So depending on the type of services, you can see that the level of control is given to the cloud provider. If you want a better control of your environment, you move to a YAS. If you want a full control, you move to your own server. Because in cloud computing is losing control. When you move to cloud, that means you accept to lose control on your product, on your infrastructure. You give some control to the cloud provider. So the level of control you have depends on the type of service. So if you are on the YAS, I control the operating system, I control the middleware, the runtime, the data, and the application. If I move to the PaaS, I just have a control on the application and the data. And in the case of SaaS, I'm just using the application. The cloud provider handles everything. This is the case for Google Doc, for example. When you use Google Doc, you manage nothing. You just click Google Doc and you use the thing. This is software as a service. So Gmail and Google Doc, everything, these are software as a services. You just connect and use it. You have no control of the application, data, anything. No, you have no control. So depending on the type of services you use, you have less or more controls. And this really depends on the purpose. What you want to do. It depends on the purpose. Because the more you give control to the cloud provider, the more you lose control, and the more you have, the less you can handle you rely on the cloud provider. So the choice of using the service depends on the application you want to do, the application you want to deploy. Do you have any question?
Not yet.
Not yet.
Okay. So because cloud computing is becoming more and more popular, there's a fast growth go in number of data centers. Because today, more and more people are moving to cloud computing. More and more people are moving to cloud computing. That implies what? The more you have a client, the more we need to build more data centers, and this brings more question about energy consumption, and pollution, and global health warming, or warming, that's the word. So the more people move to cloud computing data centers, the more you have the more you have information about data centers, about the health, everything. So this graph is to show you the evolution of from 2014 to 2019 of proportion of people moving from private cloud to public cloud. You can see that with time, in 2014, 70% of workloads were in private cloud. That means private data centers. But with time, more and more people are moving into public cloud. So, okay, we don't have to want to manage our infrastructure and we move to public cloud in order to reduce the total cost. And more people moving to public cloud, that means more these cloud providers, they have to build more data centers to host this incoming workloads. So you have some numbers on some cloud providers, but they are all, but just to give you an idea. For example, in 2012, Amazon has something like 500,000 servers. This is a lot. This is huge. In 2011, Google has something like 900,000 servers. And this represents a large proportion of these data centers, these servers that are hosted in data centers represent a large proportion of global energy consumption in the world. Because around 10% of the electric production are for ITs. These energies are there to provide energy to data centers, to cool the data centers, because servers consume a lot of energy. And when these servers are on, they heat a lot, and you need to put in place some cooling mechanism to reduce the temperature of these servers. So the more people move to public cloud, the more you have data centers that are built, and the more you have to put in place mechanism or techniques to reduce the energy consumption of the data center. So this figure gives you an overview of data centers around the world. So there are many data centers around the world. There are many data centers around the world. I'm not sure that there is any in Vietnam. Do you see Vietnam? Hello?
I see Thailand, but not Vietnam.
Yes. Ah, it
Yeah,
seems like
the
you don't
same.
have any data center. Yes, Vietnam is here. What
Yes.
It's
happened?
next to Thailand.
Yes, but what happens with Vietnam? Why don't you have any data center? So you can see that actually we have data center that are spread all around the world. So why do you have many data center? It's because actually um, when you use any services in the internet, because I suppose you people are very familiar with internet, with web programming or downloading file into the web, it's always better to have the server on which you're addressing your request to be close to you. So for example, we cannot say, okay, we are going to host all data centers in United States. That means all around the world, every time you need to use the cloud services, you have to go far away to the United States. So cloud provider, what they do is that, okay, they try to create data centers all around the world so that you will use the data center as the end user, you will use the data center that is close to you. So this is why they try to open and create data centers all around the world. You have data centers in Europe. You have many data centers in Europe. You have in France, you have in Ireland, you have in United Kingdom, you have in Germany, so you have everyone. And you have data centers United States, of course. You have in Latin America. You have very few in Africa. I think it's just in South Africa, but you have data centers all around the world. So what you have to understand that creating data centers in a country, there are many factors coming in place because one of the main one of the main constraints for cloud provider is availability. What I mean is that once you sign the kind of service level agreement with the client that I'm going to host your application and you will have a full access 24 hours over 24 hours every day to this application, you have to guarantee that. So when you decide to create a data center in a country, you should have a context that is favorable for that. That means you should have a very good energy supplier to make sure that you will not have any energy shortage or something that will come and shut down your data center for one day and we create a huge problem because client will not be able to access services. So you have many political element that comes in around to to allow the creation of data centers. See, this is why you have some country where it's more or less more difficult to have data center, because you cannot understand that in Russia you just have one data center, while in the United States you have those thousands of them. So there are many factors coming in place in opening or creating a data center. But most of the time, cloud provider, what they try to do is to have many data center on many continents, so that clients from each continent will use the data center that is closest to them, which is the most close, which is close to them. So this picture is here to show you that there are many data centers in the world, and one advice that I will give you is every time you want to use a cloud services, make sure that you use the data center that is close to where you live or where you use the service, where you want to use the service. So this is an example of this is a picture showing what it look like a data center. So this picture is from 2009. So in 2009, Amazon kind of no, is this Microsoft? Excuse me. Microsoft invest something like 2003 millions of dollars to expand its data center. So in the slide, you can see the size of the data centers. Data centers are like football fields. They are very huge buildings, highly secure buildings. So you can see it's equivalent of 8 football fields, highly secure, and very few employees that have access to these data centers. So what happens is that you have the construction of the building. Once the servers are connected, everything, you have very few people that has physical access to this infrastructure. And you have just 80 Microsoft employees to handle everything. So most of the time, these data centers are in some kind of far away from population, isolated place, and very few people have physical access to this. So in 2009, Amazon and Microsoft, excuse me, decided to expand its Dublin data center in Ireland due to the need of more computing capacity, because the demand is bigger. More and more people are using the cloud. So because in this data center, you have servers that one above, you have racks, you have many servers, one above others. There is a lot of heat. You need to put in place cooling system to reduce the temperature of these servers. So this is this is an image of a Google data center. This is an image of a Google data center, and you have these pipes that are everywhere. I think it's water cooling that are mechanism that allow to cool the system. Let me see, is it this slide? So this, I think this cooling mechanism to reduce the temperature or to regulate the temperature of servers in the data center. I didn't have anything. So this picture are just to show you what is the data center and how it represents. So data center are just like this. It's a range of computing nodes of servers, one above the other, and with huge mechanism to be able to reduce the temperature of servers. So there are many research activities, there are many techniques. I'm not an expert on that, because you have experts on data center, and there are many techniques that are used to reduce the temperature, to regulate the temperature of servers. So today in cloud computing, things are evolved, and some of the cloud providers, they are moving toward the fabrication of their own servers. What do I mean? For example, you have companies like OVH, which is a French cloud provider, which assembles that put together component to build its own server. So cloud provider, they are moving forward in such a way that they don't even want to rely anymore historical hardware provider. That means they want to be able to say, okay, I need a server with, I don't know, 4 NUMA nodes, 4 sockets with this amount of memory, and be able to assemble it. So you have some cloud provider that move forward to the step where they can assemble their own servers to put it in their own data center. To say that to the cloud provider, they are not just only people that buying servers and make it do. They are moving forward, and they are even becoming hardware providers. So for example, you see when the staff of OVH newest data center need to install a new server, they don't need to go far to find one. The huge web hosting firm built its own custom server on site at its facility. So they assemble elements and they build their own, creating perhaps the shortest supply line in the industry. So they build their own hardware, they assemble servers in their own companies. So you have OVH, Google, Facebook that build their own servers in their own sub companies. This to show that the cloud provider they are moving forward, and today they are not just software seller or hardware buyer to implement some software. No, today they are even moving forward to build their own hardware, their own servers. So let us take some a little break. Let us take some 30-minute break because I need also water.
Like,
Yes.
so the students can go back home.
Yes. Okay. Okay.
Okay,
So
thank you, teacher.
so those who are still in the office, you can go back home now. Let us take some 30-minute break so that we will continue later. Is it good for
Yes,
everyone?
yes, it's good.
Yes.
Okay. The only thing I don't just want that 30 minutes later there's no one connected. So you should people you take your motorbike and drive quickly. Go back home.
Yeah, thank you.
Okay.
Yes.
Hello. Hello.
Yes.
Okay. Is it good?
Yes.
I think that 1 or 2 students has not come back home yet.
1 or 2. Okay. Let us wait 2 minutes after we start. Just 2 minutes for them to connect. Okay. Hello. Hello.
I'm here, but I
Yes,
don't know
do we
if
hear you?
everyone has returned yet.
Oh, we will continue. Let
Yeah,
us
but we are
continue. David.
recording, so you can just continue and they will yeah, they can watch
Yes.
the record video.
Yeah.
Like, yeah. So please
The,
going.
okay. So
I'm
we're,
ready.
ju- we're just talking about the guy, the cloud provider who built their own server. So now we will move to some challenges in the cloud. Challenges of cloud.
Okay.
So cloud provider, you have many challenges. So you have the security and trust. So most of the people, they are very reluctant to the idea of moving to the cloud because of the security thing. Because most of the time we say, I decide to go and store my data into the cloud. I decide to externalize everything, and is really this cloud provider secure? Can this guy ensure me that there will be no attack on my data? Can he ensure me that there will not be any malicious user accessing my data? So there's a lot of security and trust issues into the cloud. So 70% of people um, are reluctant to the cloud due to security problem. So the question is, where is my data stored? So I don't know, I'm in France. I have my data are stored in the United States. And there are many laws in the United States, for example, that allow the government to get access to my data. So I'm always the security. So is my data really um, um, secure when I'm using the cloud? You have the privacy. Is the privacy really ensured into the cloud? And the law in the country, because there are many law regulation. And if my data is stored into a regulation that is not the one of my country where I'm living, is it a good thing? So security and trust is one of the major issues into the cloud. So we are going to talk a little bit about this security thing later on in the class, and we have a lot of regulation and compliances that you should answer to before having your application. Before you have a lot of let me show of norm, let me call it norm, that the cloud provider should provide for you to say, okay, this cloud provider, I can think of him like a secure thing. But there's a lot of mechanism to put in place to say that, okay, I as a cloud provider, I can say that your data can be protected, your data can be secure. So the security thing is a huge challenge for cloud provider in order to make the client more into this thing of cloud computing. We also have the challenge of service level agreement. So as I saw in cloud, what you have is have many clients that uses the same hardware. So you have a mutualization of resources among many clients. So when you say about sharing, you have interference on hardware utilization. So because you use the same CPU, you use the same memory, you use the same Ethernet card. So you have a lot of interference between many clients. But you as a client, you sign the service level agreement, I mean the contract with the cloud provider, and the cloud provider should enforce this SLA, the service level agreement, regardless the number of clients he has, regardless the time, regardless the temperature, regardless the natural disaster. So this SLA is the cloud provider should enforce it. So now this brings us to a situation where you have many clients sharing the same hardware, and the cloud provider should kind of answer to all of the requirements of these clients on a set of resources. So um, being able to guarantee a service level agreement with a limited infrastructure, with limited service on data center is a challenge for the cloud provider, because he has to guarantee you a level agreement, use as try to get out the best as possible from the hardware, and make sure that the client is always satisfied. So it's a kind of a very difficult equation to solve for the cloud provider. I have to make sure that my hardware is well used. I have to make sure that beside the fact, even though the hardware is used by many clients, all these clients are satisfied by the performance of my hardware. I have to make sure that, so when you put all of this together, you see it's kind of a difficult for the client to say, okay, if this client to the provider to say, okay, as this client reserve this capacity of this computing capacity, I can enforce it, because there are many users using the same hardware. There are many hardware resources that are shared, and implementing the mechanism to ensure this service level agreement is not so easy. So it's a challenge for cloud provider. So you have the energy challenge, because data center consume 1.8% of the worldwide electricity consumption. So this is to power the server for cooling, and this pollutes also the air, the environment. So there is a huge challenge in energy consumption, how to reduce energy consumption in data center, how to cool this data center. So this is also a challenge for cloud provider. You have, so These are three challenges. So for example, here you have an image of the water cooling system into Amazon, into a Google data center. This is water cooling. That may have pipes with cold water, and this cold water goes through servers, and due to the temperature of this cold water, this can help reduce the heat in servers. So there are a lot of research activities that are carried out on cooling mechanism for data centers. How to cool your server using very few, how to cool your server efficiently using very few energy. So that's the thing. So you have many mechanisms. You have water cooling, you have air cooling. So there are many research fields on that. So it's a real challenge on data center. So this is an image of Google data center with pipes for evacuating water to cool servers. So you also have this image of a water cooling system for Google data center in Finland. This is also another image. So it's just images of data center with the cooling system. So we just talked about the first three. So we have the security and trust. So the cloud provider should enforce, should kind of give motivation for the client to trust the cloud provider, the cloud provider. So after the second challenge is the SLA, service level agreement. The fact that you have the same hardware that is shared between many clients make it very difficult to fulfill a service level agreement. So because you share hardware between many clients, so implementing the cloud provider should implement politics that will allow to satisfy every client, and this is not so easy. It's a difficult thing to do because hardware resources are shared, and sharing hardware resources is not so easy. The other challenges is the energy consumption. So actually, servers consume. You have to put in place mechanism to cool the server, to reduce the energy consumption, to reduce the amount of CO2 that is produced by this data center. So other challenges are monitoring and billing. So the fact that the cloud is multi-tenant, that means you have the same hardware that is shared amongst many clients. You have the cloud provider should put in place mechanism in order to monitor the activity of each client and to build it the best as possible. Because if you remember, we talked earlier on about the pay as you go. You use and you pay. So if you want to implement a pay as you go, the cloud provider should implement a monitoring mechanism that allow you to exactly know the amount of resources, exactly know what is used by cloud client in order to build it. So put in place these monitoring mechanisms. It's not so easy because the hardware, the resources are shared. There are some hardware resources like CPU cache, for example, that are not easy to monitor, easy to share amongst many virtual machines or many processes that belongs to different users. So the monitoring and the billing is a challenge for cloud provider. For example, one of your friends told in the chat, one of his friends specified that he used the Amazon Lambda service. So Amazon Lambda service is Amazon Lambda, for example, is a service in the cloud that allow you to execute a function. And each time you execute a function, you pay just for the time of the function execution. That means if your function is executed for 1 second, you will just pay for 1 second execution. So so with a Lambda, you write your own function in a language like Python, and you submit your function to the cloud provider, to Amazon, which is Amazon in this case. And each time there's an event that you decide to, this function will be executed. So you will add the trigger, and each time there's an event that happens, your function will be launched and executed. So Amazon has to make sure that he is able to capture the exact execution time of your function in order to make you pay just for the execution of your function. So in order to be able to do that, they have to put in place mechanism to monitor the execution of function. So to just tell you that when you talk about function, it's just a code, and the execution time of a function can be in the granularity of seconds, milliseconds. So implementing mechanism to monitor application is something not easy, and this is a real challenge in cloud computing. We also have challenge like standardization. So each cloud provider provides APIs to get access to their resources. A question is, okay, I'm writing today a program that is supposed to run on Amazon using Amazon APIs, and tomorrow I decide, no, I want to move to Microsoft Azure. So it's not standardized. That means the interface that are provided by Amazon API is not the same as the one provided by Microsoft Azure or the one provided by Google Engine. So there's still a challenge in cloud about the standardization of the API that should be provided by cloud providers. So that if I describe or I build my application that is firstly run on Amazon, this application should be easily be able to be able to be deployed on Google Engine or Microsoft Azure. And for that to be possible, it's needed to put in place kind of a standardization for the interface to interact with cloud providers. So this standardization challenge is to answer to a interoperability and portability question. So is my infrastructure, is my architecture that is described on Amazon can be easily moved to something like Microsoft Azure or something else, or Google Engine. So there's a standardization challenge you have to answer to. And you also have customization. So what is also interesting in cloud is that in cloud you have many clients, and these clients are from different let me in French they call it horizon. So they are from different computer science fields. You have people from in the cloud that are doing web applications. You have people that are there for doing big data. You have people there doing e-commerce, people doing computation. So you have different peoples in the cloud, different clients on the cloud, but with different profiles of application running there. So you have an heterogeneity of profiles. You have different profiles. And it's also a challenge for the cloud provider to be able to say, okay, if it's possible for me to make sure that for each profile of cloud of clients, I can provide some specific hardware that is suitable for his workload. For example, let me take an example. If I'm running, for example, a computing intensive computing benchmark application, I need a very fast CPU with high frequency in order to have my application to run very well. So the cloud provider should think, okay, the hardware should be kind of should be suitable for this profile for this guy. That means I should build hardware that is high frequency, even because I'm doing computation, the input output is not so important. So I should build a hardware that should suit this computing workload. So the cloud provider should also facing these challenges of customization. Actually, they have to customize their services. They have to customize their hardware in such a way that they should answer to the diversity of workload that they can encounter, because there are many different workloads, there are many profiles, there are many things. So they have to think of a way to, with this heterogeneity, they to think how they should make evolve their hardware, how they should make evolve their software in order to be able to provide a very efficient services to the client. They have to customize their services. They have to customize their hardware in such a way that client workload should be run as efficiently as possible on their service. So do you get it? Hello?
We're still looking.
So as challenges in the cloud, I say you have the security and the trust. So security is a huge challenge in the cloud. The cloud provider should give guarantee to the customer that, okay, Once you use my cloud, my services, you are secure, everything is good. You don't have to be afraid. You have the cloud provider should enforce service level agreement. That means you should always be able to give to provide the service, the level of service that you agree with the client. And having this mutualization is not so easy because I have many users using the same hardware. The cloud provider have this energy challenge. They have to reduce their energy consumption. They have to look for a new way, innovative way to cool their servers, to reduce the CO2 emission in the data center. The other challenge is the monitoring, how to monitor efficiently the amount of resources that is used by servers. You have this standardization, how to make sure that we put in place API interface that allows the portability and the interoperability between across multiple cloud providers. You have the customization, how to provide services or hardware, how to make our services and hardware evolve in such a way that it can be suitable and good for different cloud application profiles. So that's the thing. So these are some challenges that cloud provider face today. So you have many research department in this cloud providing companies that try to solve some of these challenges. So what you remember when you discussed about when you introduced the cloud? I say, okay, cloud computing gives you the illusion of infinity of resources, because with cloud computing the client doesn't have an idea of the underlying hardware. That means you don't know exactly which hardware is running. So based on that, you have no control on the hardware, you as a client. So you have an illusion of the infinity of resources. So when you have this illusion of infinity of resources, it's a plus for you as a client, because this shows you that you can have as much as resources as needed for your application. For example, if I deploy my web application on the cloud, I know that if I need more computing resources, I will get it. It's not the same as when I have a server at home. I know that if when I have a server at home, I know that I have a limited amount of memory, a limited number of CPU. So in kind of when even I'm implementing my application, I'm kind of limited by these factors. So but when you move into the cloud, you have this illusion of infinity of resources. This is why you need to think about a very elastic architecture. We are going to define it. So when I say the cloud should be elastic, that means the cloud allows you to design architecture that can adapt itself according to the input load. So to give you an example, imagine you are implementing a bus, an application that allow you to sell bus tickets in Vietnam, let me say between Hanoi and Ho Chi Minh, so and Saigon. So between Hanoi and Saigon. So imagine with this application, the traffic on your application online will not be the same at any time, because for example during public holidays or during public holidays, most of the people travel a lot. So that means during the period of public holidays, the traffic on your website will be higher than normal days, because during normal time people are going to work and they are not moving from one city to another. So the application, the input load in your application is fluctuating according to the period, according to many factors. So when you move to the cloud and you want to deploy such application into the cloud, you should think about designing an architecture that is called to be elastic. That means your application should resize itself according to the input load. So for example, when I am in low period, that means period where there's a very few input load, my application should consume the least as possible resources. And when there's an increase in my loads, my application should be able to resize itself according to the input load. So in this first thing, we are talking about fluctuation of the load. So applications in the cloud are more or less used over time. We talk, as I just said, with this with this boss application, your application is in the cloud is not use the same during the whole year. So an example is an e-commerce application or anything is not the same traffic every time. So for your application to effectively or to well use the cloud, your application should be elastic in such a way that in low profile, your application is using the least resources as possible. In high profile, your application use more resources. And this elasticity allows you to avoid overbooking. I mean, because when you take, let us stick with our example of the traffic, the application to sell bus ticket between Hanoi and Saigon. So if you say, okay, I have my application and I expect for my application to have during high season 1,000 clients per day. So if you don't implement an elastic application, what will happen is that you will move to the cloud and allocate resources for 1,000 requests per day. I mean, you will do some kind of overbooking because during the low period, you are not going to use all the resources because the resources reserved is for 1,000 per day. But during the low period, you have more less than 1,000. That means you will do a overbooking. And doing a overbooking, we mean that you are going to pay for during the low period for a resource that is not used by your application. So by implementing an elastic application, I will give you an example of an elastic architecture. By implementing an elastic application, your application resizes itself according to the input load. So, and this is possible because the cloud is elastic, because with the cloud, you have the illusion of an infinity of resources. Because the cloud gives you this illusion, you can think of your application, in such a way that it can resize itself dynamically. And the overall thing is that it will help you reduce the cost for your application. So to give you an example of a elastic application, so to give a definition, elastic application is an application that increase or reduce its capacity according to the input load. So to materialize this, we say elastic application is an application that allows you to add more machines or compute capacity or reduce the computing capacity according to the load in the application. So the application is adapting itself according to the load. It's like a lung, as you can see on the picture. So when you take air, it increases. When you release, it reduces. So that's the thing. So to give you an example of an elastic application, we have this figure. So in this figure, let us stick with our travel example for bus ticket. So you can see we have a machine, we have servers. Imagine these servers are servers that are hosted in the data center. So it's managed by the cloud provider. So for you to have an elastic application, you must make sure that each time the number of clients, which is represented by this computer, by the computer with the blue screen, each client, there are too much clients, you should be able to add more web server behind without having to ask to the client to reconfigure, to request or to modify the request he sent. So in order to have a elastic application, what you do is that most of the time you use what we call a load balancer. So a load balancer is just a software, or a server is a software that allow you to redirect requests into background servers. So all the clients here, will just send their request to the load balancer, and the load balancer will redirect the request onto the web server, like in the figure. So by having this kind of architecture, when you have a low load, you will just ask the load balancer to just connect to one server, and the two other servers, you don't need to reserve them into the cloud. But when you have a high load, what you do is that you will just create more servers behind the load balancer and ask the load balancer to redirect the request to these additional servers that are being started into the cloud. So to implement this kind of architecture, you just have to replicate your web server to implement a load balancer, and according to the input load, you will increase or reduce the number of web server behind the load balancer. So having this kind of architecture is having an elastic application architecture. And with this kind of architecture, you can better use the cloud, because with the cloud, you have the illusion of infinity of resources. So by having this infinity of resources, you should implement an application in such a way that your application should be dynamic, able to adapt itself according to the input load. So you have this kind of dynamic architecture, and by implementing this dynamic architecture into the cloud is good, because you fully use the potential of cloud. Do you get me? Hello?
Yes.
Do you
Yes.
have any question?
Not yet today.
Yeah, not yet.
Okay. Not yet. I hope you will have question.
Because I
So
think this is the basically a basic information for cloud. So before some information I have learned and I research related to our work. So I think no question now. Yeah.
okay, good. So in cloud, as I told you, cloud basically now we are going to introduce, because it's tomorrow we are going to do the visualization. We have a whole week together, so it's going to be a very long week. So I'm going to give a basic definition of visualization, because we are going to do a practical class just behind with this. So in cloud, as I told you, one of the most important word um, is mutualization. So you share the hardware amongst many clients. And in order to do this, the cloud provider needs some software that allow the sharing of hardware resources. So historically, Amazon, most of the time, what they did is, at the beginning, each client was having an access to a full hardware, to a dedicated machine. But they say no, it's a waste of resources, because sometimes a client doesn't use the full servers alone. So they decided to move to a solution that is more suitable, which is virtualization. So virtualization is a process of running virtual instances of a computer system, that running the operating system in a abstract layer from the actual layer. So so virtualization is simple. Is, as you can see in the in the figure, it's just a system where you have multiple operating systems running on a single hardware, and this operating system is running in a abstraction that is known as virtual machines. And all of this is possible with what we call a virtual machine monitor, VMM, or a hypervisor. So the hypervisor is a software that's allowed to share the hardware resources among multiple virtual machines. So tomorrow we are going to go deep into this visualization thing. So virtualization allows the sharing of hardware amongst many virtual machines. So it's kind of an ideal solution for the cloud provider, because it allows the multiplex of the hardware. So the cloud provider does say, okay, we need to share the hardware amongst many clients. So why not just use this technology of virtualization to share it? So by using this solution, there are some challenges. You have security challenges. You are going to discuss about that tomorrow. You have performance, and you have also failure. So security, that means because you have many virtual machines that are running on the same hardware, that are sharing the same hardware resources. Um, a virtual machine should be protected A virtual machine has to be protected against potential attacks of other virtual machines. So the virtual machine monitor should make sure that a virtual machine cannot be attacked by another virtual machine. And also you have performance challenges in the cloud, which is actually the fact that you add a software layer, which is the hypervisor. This adds some overhead on the performance, on the execution performance of application in virtual machine. So there are many work on how to make sure that the performance of application in the virtual machine is still as good as when you run the application directly on the hardware without virtualization. And also the fact that many applications are using all these virtual machines are using the same hardware. That means the performance or the activity of one virtual machine can kind of impact the activity of another virtual machine. So there's this performance challenge, which is my application fast enough as when the application was running on a bare metal system, or the activity of a virtual machine is the activity of a virtual machine affecting the activity of another virtual machine. And you also have the failure. The fact that many virtual machines, many operating systems share the same hardware is that if a virtual machine has a problem, if there's a failure on a virtual machine, does this failure impact other virtual machine? So there are a bunch of challenges that are related to virtualization. And these challenges should be answered by an hypervisor. Tomorrow we are going to talk about it. So I think this part we are going to do it tomorrow. So let us first go to the lab work. We are going to do a very nice lab work. Do you have any question on what we discussed? Because 4 hours.
No, let's look at the lab work first, and then we will have plenty of questions.
Yes, because talking for 3 hours is long. I'm kind of tired of talking. Whew. A little bit. Wait a minute, let me look for it. Okay. Okay, now I'm going to send you this and you are going to do this lab work. So you are going to use a little bit of Amazon Web Service. You are going to use the EC2 service. So I basically have an account on Amazon, and on this account I created some sub account using IAM services, Identity Access Management Services of Amazon. I created some sub account for you. So you people are going to connect to Amazon using this sub account. And on this sub account, you are going to carry out this lab work. So the lab work consists on using EC2, create virtual machine, connect to this virtual machine, deploy an application in this virtual machine, and deploy an application in this virtual machine, implement and configure a load balancer in Amazon, use the auto scaling services of Amazon. So you are going to first of all connect to the EC2 service. I'm going to give you credentials so that you can connect to the Amazon things. And you are going to create a security group, configure a security group, configure the access to this security group, start a virtual machine, select the virtual machine, select the operating system in the virtual machine, configure the virtual machine, and start the virtual machine. After that, you will connect to this virtual machine. And in this virtual machine, you are going to install a web browser, Apache 2, a web server. In this Apache 2, you are going to deploy an application, a very simple application. You are going to save the image of this virtual machine and create a virtual machine from this saved image and terminate it. After, you are going to use the Amazon auto scaling services. And to use it, you are going to first to configure a load balancer. I'm going to define you later on when you will done with the class. I'm going to talk about the Amazon auto scaling services. So you are going to create a load balancer, configure this load balancer, create it, configure it, do everything, do everything, configure the load balancer, attach to the load balancer instances of virtual machines, test if the load balancer is good, create the launch configuration for your auto scaling, do everything, configure the auto scaling, and check if the auto scaling is working. So it's a kind of simple lab work. So it's not difficult, it's very simple. So you are going to start do the thing. Every time if you have any question and answer, I explain to you. After some time, I will explain to you what is auto scaling thing after the first part, because the first part is just creating virtual machine, storing it and everything. After that, I will explain to you what is auto scaling configuration and tell you how it works. So let me send you the file. Okay, I just sent you the file. So now to get access to my Amazon account, let me give you credentials. So in the chat, I just sent you a link. You will have to keep this link because most of the time you need more than 1 hour to be able to do the lab work. So tomorrow we are going to use the same credential. So I created for you users, a list of sub users, as I just said to you. So the identity, the username is user X, and the password are password X, and X is from 1 to 12. So each of you in the chat, you should select a number X. I mean, you should select, am I user 1, am I user 2, am I user 3, am I user 12? And you connect to Amazon services using the username and the password associated to you. So if, for example, I say I'm user 1, that means my username will be user 1 and my password will be password 1. If I'm user 2, my username will be user 2 and my password will be password 2. You get it? So now try to connect to Amazon. So you people should select in the chat, say, yes, user 1, I am user 1, I'm user 2, I'm user 3, so that you don't overlap. You see, both of you have 2 people using 12. So type on the chat so that everyone will know exactly which user is already used, already occupied.
Teacher, are you there?
Ai login được không nhỉ? Hello.
Không login được.
Đúng không? Không login được hả?
Không login được.
So which one cannot sign in?
Yeah. Cannot login.
User 1?
Everyone, user
Everyone.
11.
Yes.
Yeah.
The message.
Everyone?
Yes.
The authentication. Correct.
When you click, don't change the account ID. Don't change the number.
Yes, we don't change.
Yes, we didn't change.
No change.
Okay. Let me try.
Up okay. P. Really? Yes, maybe. Yes. Okay. P capital.
It's P capital.
Yeah.
It's P capital. Sorry.
Oh.
It's P capital for password.
So log in with Francais.
Yes.
Oh,
It's okay now.
it's English.
Language.
You can. It's English. Normally, it's English. It's not French.
Friend.
Yes, it's okay.
Chuyên gia tiếng Pháp chỉ chữa đổi cấu hình ngôn ngữ.
Ô, thầy gửi bài lab vào đâu nhỉ anh em?
Chat. Chat.
Chat á?
Cái file
Không,
thì gửi trước.
cái file nãy thầy show file lab mà.
Đây, file trước gửi cái link ấy trên cùng. Amazon Service này.
Đó, đấy là cái link login vào thôi. Còn cái thầy có
Trên một file. Nhưng mọi người giao diện tiếng Pháp hay tiếng Anh đấy?
Mọi người mà chậm ấy thì mọi người chuyển sang vùng của Singapore ấy, để bên Pháp chậm lắm. Góc trên
login vào xong vào tiếp phần nào ấy nhỉ?
Làm theo ấy, làm theo cái file doc này.
File doc nào gửi cho anh? Sao anh không thấy file doc nhỉ?
Em đang tải chưa?
Em tải nãy giờ cũng chưa xong. Ai tải rồi gửi cho em đó.
Tải ở nguồn nào đấy? Anh không thấy.
Đây, gửi cho vào nhóm nhé.
Trong khung chat đấy em.
Chat này.
Khung chat đấy. Anh không vào nên anh không nhìn thấy cái đoạn này.
Nhưng mà cái phần support language thì có ai không? Đấy, gửi file trong
Language thì anh kéo xuống phần góc trái bên dưới màn hình.
Góc trái á?
Bên dưới màn hình ấy. Có gần chỗ feedback ấy, feedback language ấy.
Ok, thank you.
Còn ai mà truy cập web Amazon chậm thì chọn sang Singapore ấy. Ở góc trên bên phải. Em truy cập bên đấy chậm lắm.
Đây là đang
login này. Choose service.
brand ở đâu?
Chọn ở đâu một security group. Security group.
Mình sẽ tạo một cái create security group mới à?
Đúng rồi.
Nó có sẵn một cái là mình vẫn tạo.
Cái rule đấy có cần phải tạo không nhỉ? Inbound rule với outbound rule.
Rồi,
Ở đây là thế có
để tạo mày truy cập được từ bên ngoài vào.
Tạo key pair trước, xong rồi đến mới tạo security group.
Key pair để connect với cái server đấy.
Key pair.
Không nghe nó. Hà.
Key pair. Security group.
Mình nhìn thấy cả Teabe, Kiều Cloud.
Hiện danh đấy nhỉ?
Sao lại hiện ra được nhỉ?
Nhìn thấy hết. Nhưng mà chỉ nhìn thấy 3 người, những người khác thấy.
Kêu em ơi.
Bây giờ này có thể
Ồ, cái security group có phải tạo thêm nữa không anh? Nó có một cái default rồi đó.
tên nó
Dạ,
tạo mới.
tạo một cái mới.
Anh dùng luôn, thử luôn cái rule đấy luôn.
Cái outbound không thấy chỉ dẫn tôi như nào nhỉ?
Để mặc định em, không cần cấu hình cái đấy.
Nó là on traffic custom. Không phải bấm nút create đúng không?
Cái tai của Ru thì on traffic à?
Đây, nhìn hình này, on traffic và anywhere.
Nhưng mà on traffic thì không ra được cái port range.
On rồi, port range của mình là on. Của thầy chỉ là từ 0.6 5.000 của mình là on này là chưa hết. Thông tin của mình là ít hơn so với cái của thầy nhỉ.
Ủa mọi người ơi, sao cái inbound của em nó bị báo là no inbound rule nhỉ? What?
Instant.
Cái gì?
Cái bản của thầy với bản của mình là khác nhau hay sao?
Vâng.
Thấy cái button này nó ở vị trí khác.
Anyway.
Select.
Cái đấy là chọn 64 bit x86 hay là ARM nhỉ? Các x86 nhỉ?
Làm sao là 32 bit à?
Cái nào cũng được anh.
Nó là 64 bit.
Group của mình là bị open, ai cũng vào xem được. Ở đây giờ bài edit security group này. Cube là của ai không biết.
Cube.
Cube. Nó đặt cho cái nick này.
Cube là của Kiều à?
Có của anh Dương. Em ơi, từ khi được Nam đặt cho cái tên đó anh Dương kiểu suốt ngày dùng.
Cube.
Thích quá.
Cho Cube và sẽ thuê tí xem tí Cube.
Đang số hình được.
Lan instant. Ủa tại cái group xong rồi làm gì nữa mọi người? Sao của em nó nhìn khác của thầy quá.
Cái cũng quá nha. Dương này làm đúng cái đăng này, cái Daniel này.
Ủa sao mọi người đặt tên giống nhau, có mỗi em khác? Chết rồi. Có sao
mẫu.
Đặt theo mẫu của thầy thì
chả sao.
Yeah.
Nam với ông Long rồi ông Huỳnh, ông Đức đâu rồi? Không thấy nhỉ?
Em có đổi tên được không ta?
Đâu rồi?
Em là đổi tên. Edit. Delete.
Đến cái bước public address VM, sao mình thấy cái màn hình của mình của thầy này khác nhau nhỉ?
Cái là của mình nhỉ?
Yes. Instance.
Group name của Billy lại
Rồi, thấy của dê con rồi, dê già đây rồi.
Oui, je vous appelle par rapport à une annonce immobilière que vous avez postée sur le Bon Coin. Un appartement T3 à Sainte-Anne.
Management. Instant.
Oui, c'est ça.
Instant.
Ah, il a été posté aujourd'hui, il est déjà vendu.
Em quên cái gì đấy?
Ah, d'accord, parce que s'il a apparu aujourd'hui, je me suis dit, ah, oui. Ah, d'accord. Ah, non, c'était le 7 janvier. Ah oui, c'était le 7 janvier. C'était même marqué urgent. Putain, je suis con. D'accord, d'accord. D'accord, merci.
mình là tiếng Pháp thì phải
D'accord,
sợ.
merci. Ah, c'était une bonne affaire, ça.
Nói chi xong kêu
Eo.
D'accord, merci.
Kiểu ra một tràng này cho thầy khiếp.
đồng ý hơn là chỗ này.
Lunch.
Ban có
VM là cái gì em ơi? Khoan. Ubuntu server.
Mọi người đã public được cái DNS chưa? Public address, sao anh không thấy cái link đấy nhỉ?
còn thì khác này.
Đúng cái link giống Instant ID, Instant Time đây rồi. Status check. Đây của thầy là Instant State, xong rồi đến Status check. Ở đây running. Đúng rồi.
Giao diện thầy hơi cổ, hơi cũ ấy nên là
Nhưng mà mình có một cái lỗi.
Amazon mà mất
Là user 9 not new form.
Oui, bonjour. Je vous appelle par rapport à un bien immobilier que j'ai trouvé sur le Bon Coin. Une
Đây con
de votre agent.
cái link để public DNS.
Même à l'achat.
em nói đấy, một người nói thôi.
C'est un 3 pièces de 63 mètres carrés à Sainte-Anne.
Em có thấy cái chỗ public DNS thầy không?
Có. Em chọn Winston chưa?
Bấm cái
Chọn rồi.
IC2.
Dans les environs, oui, des 190 T3.
Thấy đâu cả.
Em ban chụp màn hình.
Oui, 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 c'est pour y habiter moi.
Chụp màn hình nhá.
Người có bị cái lỗi như của anh không? Ở Dương có bị lỗi
Lỗi gì anh?
anh copy ở trong dưới cái màn hình DNS này thì nó có một cái báo là cái
Ah, quand on est sur la terrasse, on entend la rocade.
not authorized to burn.
Mọi người
D'accord. Est-ce
đọc
que
tên cái
je pourrais avoir l'adresse exacte parce que je vis dans le secteur en fait.
đặt như cái
C'est
tên, đặt tên.
Alfred, je peux avoir le... Je suis devant un ordinateur, je tape Alfred Rambaud. Oui, il y a une Toulouse.
Đấy,
Et oui,
Dương thấy
Alfred
cái màn
Rambaud,
hình không?
ouais, c'est ça.
Đến cái màn hình
Ah oui,
đến cái
c'est
bước này
complètement collé à la rocade en fait.
nhìn thấy
Rồi,
cái
rồi em thấy rồi. Em kéo cái folder nó lên đi, nó bị thiếu thông tin.
Donc, ça veut dire qu'il y a une nuisance sonore.
Euh.
Il y a une nuisance sonore.
Em thấy chưa?
Đây, nhìn thấy rồi.
Je vois.
Update address.
J'aurais une question, c'est marqué sur le
Mình
site
có phải ấn vào open
c'est
address không?
aux enchères IMO. C'est quoi ce truc en fait?
Ấn vào để test thử cái xem.
Bình Dương không bị cái lỗi như của anh à?
Bị lỗi gì anh? Em có biết
vous
đâu.
l'avez mis aux enchères et
Đoạn chat everyone
ça donnait grand chose.
Đâu nhỉ?
Ah d'accord. Ah donc c'est possible de mettre ton bien aux enchères et on voit ce que ça donne.
Ở cái màn hình ở phía dưới thông tin DNS đây, detail ấy. Nó có
Anh
cái lỗi.
D'accord.
Màn hình ở đây.
Bon, je sais pas s'il faut que je visite parce que la nuisance sonore d'après vous elle est présente ou on entend vraiment la rocade.
Anh chat có nhìn thấy đoạn chat của anh không?
Chat ở đâu? Trong group đó à?
D'accord, je pense que ouais, c'est peut-être ça. Je vais passer puisque je vis juste à côté en fait. Je pense que c'est peut-être ce que je vais faire. Je vais passer à côté et je verrai.
À cái đấy không sao đâu anh.
D'accord. Je le ferai. D'accord, ok. D'accord, merci beaucoup.
Dây dài có bị không?
Đây. Chính là cái lỗi mà
anh cũng bị cái lỗi not before.
Thầy không cấp quyền cái chức năng đấy thôi. Sao đâu?
cái lớp hoặc là sao chạy được đúng không?
Bây giờ SSH à?
Đây này, chỗ này phải dùng máy Mac rồi.
Từ đây em bảo có một cách nó đơn giản hơn này. Mọi người ấn nút, mọi người chọn cái instant mọi người muốn connect đúng không?
Allô?
Mọi người ấn nút.
Someone send me an error message.
Yes, I have errors, so or warning, so it's okay or not? You can check for me.
Yes,
user.
And other people need also.
Do other people have the same error?
Yes, we have. We also have this error.
You also have this error.
Yes.
And on which data center are you running? Can you see the
which? You mean the location?
Yes, the location.
Ohio.
Let me see.
Xem cái location đâu ấy nhỉ? Dây dài nhỉ?
Cùng góc trên phải.
But I saw that there are many operations you people try to do. I see, for example, user one, you try to get account summary. You try to do that. User one, list account aliases.
Yes.
Why did you try to do that? Why do you just go and work with EC2? You don't need to.
What do you mention? Because I do as a guideline.
Did you follow the guidelines and?
Yes, I follow.
You were not able to create virtual machines.
Pardon? Can you repeat again?
Because I can see that some of your friends are able to create virtual machines without any problem. You have the same types of accounts, so there's no reason your friend can do it and you cannot. So how many of you do have the problem? Do you have, how many of you have problem creating virtual machines?
Up to now, we have 2.
Me, 3.
Okay, 3 people. We have 3 people. What's the same problem?
You have the same problem.
Yep.
Okay. So what you the 3 of you are going to do is you are going to change the location.
Ohio 2.
Yes, change it and move to another location. Wait a bit.
We change
To California, Oregon.
California.
California.
Can I change to Hong Kong or something like that?
Yes, you can change to Hong Kong if you want.
The permissions.
No, you people should stay in the United States. So either you move to California or you move to Virginia. Don't move to Hong Kong.
Okay, so I move to California.
Nhưng mà em move xong phát hình như nó mất luôn.
Đúng rồi, phải tạo cái mới hả anh? Anh instant thì lên thôi.
Dương
Thì bị mất cái instant đấy luôn rồi. Phải tạo lại instant.
Ông
Tạo lại
Dương chọn cái instant của ông Minh
Dương. Làm nào đặt tên instant đây, bây giờ đã không biết là ai là instant nào của ai.
Em có nút em trước cái tên ấy.
Wow. Chết rồi, nó mất luôn cái group rồi.
Teacher.
Dương chụp ảnh của em không nhìn.
Mọi người đổi instant là mọi người đổi sang vùng khác thì nó mất hết tất cả những cái phía trước đấy mọi người tạo.
Làm lại từ đầu à?
Làm lại từ đầu.
Anh vẫn tạo cái key name đúng như thế thì liệu nó có bị trùng không?
Không anh.
Nó không có key file luôn ấy. Phải tạo lại từ đầu.
Không, nhưng mà tạo từ đầu nhưng mà em dùng vẫn cái key đấy thì liệu nó có bị làm sao không? Chỉ
không được, nó không hiện cái key ra cho em chọn luôn.
Không, ý là
anh tạo một cái key mới giống tên cái key cũ hả?
Phải tạo cái key mới.
Vâng.
Cái tên...
Nhưng mà tên giống thì kệ nó chứ đâu sao nữa.
Thế
lại phải tạo lại từ đầu.
Vâng. Yên nhỉ. Biết thế này chuyển qua Singapore ngay từ đầu như anh Minh Dương bảo.
Thực ra phía trong cái instant nó có cho mọi người tạo hết tất cả mọi thứ rồi, mọi người không phải làm từng bước gì.
Vấn đề là không biết cái lỗi không ấy. Minh Dương là không bị lỗi đấy à hay cũng bị lỗi đấy?
Lỗi gì vậy? Cái optimizer finding này à? Bị chứ.
Ôi, thế thì đổi làm quái gì? Đấy, em cũng bị mà.
Nó không ảnh hưởng.
Hả?
Nó không ảnh hưởng. Em vẫn tạo được, vẫn chạy được, vẫn connect được.
Thế thì thôi, đổi là gì nữa đúng không? Mình quay lại O22 đi.
Em cũng nghĩ thế đấy.
Đổi gì mất công. Lại gì mất công.
Thôi không đổi nữa đâu. Vào O22 chơi.
Rồi bây giờ quay lại xem là tìm lại cái chỗ.
Tiếp theo thì làm gì nhỉ?
Check. Còn lại bây giờ là check bạn. Name.
Đâu rồi? Rồi thế nhiều đây là thấy Lê Huy Đức đây rồi này. Còn ai nữa này? Kiều không đặt tên hả Kiều?
Đặt tên cái gì anh?
Đặt cái tên của cái instant của em ấy.
Ủa chứ rồi sao đặt đấy em?
Em vào là instant em đặt được mà. Để anh đặt cho.
Ủa được hả?
Kiều nữ nhé.
Ủa nó đâu nhỉ? Thế giờ quay tự nhiên đổi rồi.
Đấy, anh đổi cho rồi đấy.
Phải đổi qua Ohio đúng
Cái
không?
gì?
Bây giờ nó cứ tên của em.
Nhưng mà anh vào cái open address, cái public DNS ấy, nó bị lỗi ấy, nó không ấy được, nó không truy access được.
H1
Đến cái đoạn connection with SSH thì mình lại phải dùng ấy à? Bây giờ là phải dùng command nó. Cái này là Ubuntu.
Nếu ai dùng
Mình
Windows thì anh cách này cho dễ.
nhưng mà
Windows
Mac không được là thế nào nhỉ? Nó bảo là no set file. À không phải rồi, chỗ này.
Đây, em bảo với mọi người cách connect này, mọi người ấn vào cái instant của mọi người nha, ấn nút connect.
nhận
Dạ.
vào instant, ấn instant này. Connect ở đâu?
Nút ở
Ấn
trên
connect rồi. Rồi, nhìn thấy rồi. Connect xong.
Trong ai mà muốn connect bằng Mac ấy thì kích vào cái tab SSL client.
SSH client.
Đúng rồi, follow theo cái đấy.
Còn Windows sao?
Còn nếu Windows thì chọn tab đầu tiên.
EC2 Instant Connect đây đúng không?
Trong cái username mọi người có Ubuntu. Trong ấn nút connect nó sẽ mở ra một cái tab browser để connect. Đấy.
Bao giờ để connect? Minh Dương dành này thế nhỉ?
Em làm nó suốt ngày.
Sao anh để vào Kiều Trần nên là sao anh để vào Kiều Trần nhỉ?
Thì chắc là do anh ấn nhầm.
Sao lại phải quên?
Đừng ơi,
Đến vào nhầm Kiều Trần đấy rồi.
cái Open SSH client thì là mình mở cái console thôi đúng không?
Đúng
cái
rồi,
terminal thôi đúng không? Sau đó
rồi.
locate do private key file là mình là như thế nào?
Cái key vừa rồi anh tải về, anh có ấn tải về không?
Chứ không tải.
Toang rồi.
Bây giờ phải tải về à?
Thôi, lỡ mất key rồi thì thôi. Làm bước đầu tiên.
Vẫn có tên mà sao phải mất?
Anh tải về key.
Nó thầy có bảo tải về đâu? À đây nó tải về, nó tự động tải về rồi đây, quên nhỉ. Đây nó tải rồi. Lúc nãy nó tự tải rồi.
Thì anh CD vào cái thư mục có key rồi làm bước 3.
Cái đấy anh lại đang để trên máy Windows. Thế bây giờ anh phải move.
Chứ rồi mình ấn nhầm vào của Kiều nữ thằng nào.
Thế là bây giờ anh sẽ gửi mail, anh lấy cái đấy key ở trên Windows chắc không ảnh hưởng gì đâu. Anh lưu cái máy Mac là được.
Username như mình đặt thế nào cũng được ấy, chứ không là phải đặt Ubuntu. Còn đấy cái nhưng mà sao anh vào anh thấy nó đen thui thế ở Minh Dương?
Chờ nó connect, anh chờ tí xem. Bởi vì anh có connect bên Ohio nên mạng hơi chậm.
Vấn đề cái gì nhỉ? Cái này Cái này liệu làm Windows có đảm bảo không? Sợ về sau lại bước sau lại phải làm Mac.
Không ạ,
Hoặc
như
là
nhau. Không.
Anh ơi, sau khi em connect xong rồi thì em
chuyên nghiệp
đặt tên cái username đúng không? Xong rồi connect lần nữa hả? Có cần phải chuyển qua SSH hay là gì không ạ?
Anh Ban ơi, cái connect Windows nó không được rồi, thằng chậm quá nó không connect được rồi, chắc phải connect bằng terminal rồi. Terminal thì mọi người tải một cái gọi là trên Windows thì mọi người tải cái này để cho em.
Cái nào?
Từ từ cho em thì em gửi vào nhóm. Mọi người lên
Putty này, cái Putty này là trước anh dùng để kết nối vào server của VTH Lab đây này.
đấy, giống nhau hết đấy.
À,
Nếu như mà Putty thì lúc đấy anh phải tạo cái file pp.ppk anh Ban ạ. Còn PEM thì mới là SSH.
Đấy Nam dùng cái Putty kìa, cái terminal
Nếu
đấy.
mà anh muốn làm Putty phải làm lại mà.
của Nam là trên Windows hay là gì đây nào?
Nam Windows dùng Putty.
Putty cũng được mà thôi mình làm Mac thì không làm.
Đúng rồi, làm Mac hiệu quả.
Chuyên nghiệp.
Làm Mac cho nó khỏe.
Mọi người ơi,
Ơi,
em gửi hình đấy, em đang ở đấy rồi, bây giờ em làm gì tiếp này?
Ở đấy cứ đứng đấy. Đừng đi đâu.
Em đang đứng im.
Kiều. Kiều đây à? Kiều ấn
Vâng.
vào SSH client đi Kiều.
Rồi ạ.
Rồi em làm
Cách là cái địa chỉ ấy đúng không nhỉ?
em làm
anh
từ
Dương ạ. Sao ạ?
em làm từ bước 3.
Bước 3 ở trong cái của thầy.
Em mở terminal lên rồi em gõ, em tải key chỗ nào thì em cd terminal vào cái chỗ chứa key đấy, hình chắc trong download đấy.
mình phải chuyển sang mấy Mac làm.
Xong em copy câu lệnh example kia vào là chạy là xong.
Để em tí.
400. Thế mà 400 hình như cũng tương đương bằng cái đấy của thầy phải không nhỉ? Tương đương như cái Go RXVK. RXVK này là tất cả là 7 nhỉ? Đây là full quyền. Của mình là 400, có nghĩa là chỉ có thằng đầu tiên được XQ hay gần RIP. H1 400 QQ. Go.
Chứ rồi sao em chạy cái bước 4 thì nó bảo là command file nè.
Còn cái vị trí kia. Nhờ cái này zoom đi nha, anh em đừng bận tâm nhé. sẽ hỏi một câu là you still want to continue. Khi mà kết nối mọi người có bị cái warning là the authenticity of host này can't be established không nhỉ?
Em có.
Chắc là tự biết rồi. Kệ. Nó bảo you sure want to continue connecting.
Đúng. Cái gì nhỉ?
Continue.
Tên gì cái này lại.
Rồi, xong rồi vào màn hình kia rồi.
Tí tí. Hôm nay học bằng cái này như này.
Con học bằng chị Linh ơi, có gì cho em mượn lại mấy cái móc hôm bữa để em thay đổi.
Kìa, nói gì đấy. Dương BM stopped, Đức là hát shooting down. Đó là sao? Okay. Thầy đi chơi rồi sao?
Ồ anh bây giờ làm gì tiếp theo vậy? Alo. Mất tiêu rồi. Không nghe được luôn. Em connect xong rồi.
Em gọn lấy không nào ấy. Vào terminal.
Bây giờ tới cái bước mà install cái Apache ấy hả?
Đúng rồi.
Ok.
Đức delete được instant chưa?
Cái anh vừa gửi ấy, cái file SCP đấy là mình phải cái file mà đuôi fix.pem đấy thì cứ phải đổi tên không nhỉ? Còn
Là
cái
tên của cái file của mình.
có phải được không?
Này,
File của mình.
Có
Thế còn
chứ.
cái địa chỉ cũng là địa chỉ của mình đúng không? A còng ấy.
mọi người mở được web lên chưa?
Mở được web rồi.
Ê, khoan cái web của mọi người như thế nào vậy?
Đúng địa chỉ web luôn đúng không? Địa chỉ web chính là cái địa chỉ mình Ubuntu A còng ấy, mở đứng đoạn đấy là xong rồi.
Của anh lên à?
Của em nó là
Nó sẽ ra cái trang avatar Ubuntu.
Ủa sao cái web của em nó lại như này? Mọi người có bị như vậy không?
Đây là gửi cho mọi người nha. Mọi người thử xem có truy cập được cái đấy không. Đấy. Bố Dương không ăn nổi đâu. Đấy địa chỉ đấy vẫn truy cập được đấy, cái đấy của anh.
Dương lên thế đi đúng không?
Anh Minh Dương ơi, của em.
Của anh nó cũng
Của
không
em bị
lên thôi.
sai.
Anh nó không còn truy không.
Lúc nãy anh thấy cái máy instant của Dương là nó bị gì nhỉ? Nó bị stop mà.
Em
Thế
cố
em
tìm
stop ra nó đi à? Em stop đi đúng không?
em chạy lại nhưng em không biết là nó bị ở đâu. Buồn ghê.
Nam ơi, cái chỗ mà from your machine ấy, gõ cái lệnh SCP ấy là vẫn đang ở cái quyền root, quyền pass của cái file ấy đúng không? Hay là mình tạo ra một cái console mới xong mình vào?
Thì cái đấy là copy file từ máy em lên trên server đấy. Đấy.
Copy từ máy server đúng không? Như vậy là dùng cái màn hình thì cũng được chứ không phải dùng cái login kia đúng không?
Ôi con ai kêu anh Dương hả? Thế
Không, cái SH vào server rồi, bây giờ phải cài cái Apache PHP 5 à?
vâng.
Cái đấy nhưng mà cái lệnh SCP này mình sẽ gõ từ chỗ nào nhỉ? Từ cái đường dẫn thư mục có chứa file của mình đúng không? Chắc thế. Con số mới xem nào.
Ồ mọi người, cái file index.php là ở đâu ấy? Ủa, đâu có ai có file đấy. Anh Sugar. Anh Sugar ơi. Cái file index.php của anh có không?
Đấy thì anh mới đang không biết là mọi người đang thử đây. Vấn đề là cái file fix.pem là mình phải thay bằng cái key của mình đúng không? Mọi người đang thế đúng không?
Vâng ạ.
Rồi thử tại
sao khoan mà anh chạy cái dòng này ở đâu?
Đáng ra như thế trong file của thầy là file key đăng mà nhỉ? Key đăng.pem thì tại sao tự nhiên lại có cái tên là lạ này? Anh đang hơi nghi.
Thôi chứ thầy copy ở đâu đấy đó mà.
Sau đó là index kệ nó đúng không? Sau đó là cái Ubuntu A còng là mình lấy cái địa chỉ của mình thay vào. Thì cái dấu 2 chấm còn nhỉ?
Chấm với dấu chấm là như nào đấy?
Dấu 2 chấm xong đến dấu chấm.
Kệ hả? Kệ luôn anh. Anh ơi mà cái dòng này chạy ở đâu vậy ạ?
Anh tạo ra anh chạy ở cái chỗ thư mục có chứa cái file PEM đấy. Để copy mà lệnh SCP là lệnh copy.
Dạ là chạy trên máy.
Chấm không?
Anh cứ chạy thử đi.
Copy rồi.
Chết dịch.
Nếu mà 2 chấm thì phải có port chứ. Đấy, lỗi này. Hai chấm cũng lỗi. Dấu chấm cũng lỗi. Đấy, nó báo là mình dùng sai câu lệnh.
Tại mấy mác có vẻ nhanh hơn thật.
Em tưởng là có cái con gì nhỉ? Cái gì nhỉ? Cái con mới gì của anh? À nói tiếng Anh ghê quá vậy. Em mấy con anh ba.
Con nhà anh nó đang học.
Tiếng Anh nhất kinh thật.
Nói hơn cả bố. Ghê quá.
Đấy thôi, thế trong video thôi.
Minh Dương làm cái lệnh SCP đấy chưa?
Chưa anh ạ.
Đấy à? Nam làm.
Minh Dương đang gặp lỗi. Nam cũng đang không làm được.
Để tự nhiên lại bảo delete cái instant là cái gì, làm đến đoạn nào?
Còn dài phết đấy, mình mới làm được một tí, còn bao nhiêu dưới này đấy.
Mới trang cơ mà.
Tiếc quá. Này phải làm đến đêm mới xong.
Rõ ràng.
Vãi luôn.
Mình đang chơi nghĩa của cái thằng này. Thằng này có nghĩa đi cái PEM, trong cái file PEM đấy hình như nó có cái index PHP này lên cái địa chỉ chỗ kia. Đấy, kiểu như thế. Nhưng mà cái dấu này chắc là do mình làm cái này sai rồi. Cái dấu này là
dấu gì?
cho cái dấu nhọn nó phải xóa 2 cái dấu nhọn, chắc là phải xóa 2 cái dấu nhọn đi.
Em xóa rồi nhưng mà nó không có được đâu.
Đây, anh gõ xong phát nó không kiến gì nữa này. Có lỗi gì đâu, nó ok luôn mà. Nhưng không biết là sau đó anh sẽ sudo
anh nói
path.
từ cái chỗ anh verify cái trang kia kìa, nó có ra giống cái trang của thầy không?
Modify cái gì? Trang này.
Ở cái slide trên của
Có
cái giống ở trang của thầy luôn hả?
Giống như hệt luôn.
Nhưng mà cái em không phải.
Chỉ là cái địa chỉ của mình chứ không phải địa chỉ trong cái thầy đâu, đúng không?
Địa chỉ của mình là lấy chỗ nào vậy à?
Cái chỗ SSH Connect ấy, chỗ anh Minh Dương anh chỉ Connect có cái tab ấy, nó có đúng cái địa chỉ đấy mình gõ là xong.
Wow, cái rồi của em.
Chính là cái địa chỉ
chỗ này quá.
Chính là địa chỉ mình Connect ấy. Còng ấy, chính là cái chỗ Xong rồi. Bây giờ trên máy ảo này thì mình lại sudo path này. Mình sudo đây rồi. Sudo path là chẳng qua là sang root thôi. Mình đang ở thư mục đấy rồi, mình là s bvkd
ttb
rama.
Điên rồi. Ok. Được.
Movie index.
Anh ơi, anh đã chạy cái kia được chưa?
Nó báo là không thấy cái file index.php đâu, chứng tỏ là chả cái lệnh kia copy nó không lên.
Hello.
Alo.
Hello.
Yes. Is it good for you?
Not good.
I cannot.
Do you have any problem?
I have problem when I try to run the command scp to copy the index.php to the virtual machine.
Okay. Do you have the index.php? That's the first question. You just have to create a stupid PHP application that just print hello world.
I'm not sure. I stop the problem here. Slash trang bao nhiêu? I install Apache 2 and PHP 5 is okay, and verify that Apache is functioning is okay from web browser, but continue is not okay because I cannot copy index.php. I'm not sure I create before.
Create a file index.php on your machine and you copy it. So create a file index.php, you put this content. It's a really stupid content that just presents you information about a PHP. You create a file index.php on your machine and you copy, you paste this content. I just send it on the chat.
This is the content of the index.php?
Yes, this is the content. Just put this content. And
so
after that,
I create the zip file and locate with the same directory with the key file.
No, what do you do? Try to share your screen so that I can help you. Share your screen.
Yes. Okay. Hot disable attendee screen sharing.
I have to. Okay, it's good now.
Yes, okay. I can share. Share on or share.
Anh ơi, cái chỗ đó anh làm như nào vậy?
Share như nào nhỉ?
Đâu nhỉ?
Share basic.
Không.
You can see my screen?
Yes, I can see it.
Yes.
Okay,
Yeah.
good. Try to do Control L. Let me clear screen. Control L. Yes. Okay.
Escape?
No, Control L. Control L. Control plus L.
Control N. What does it mean?
Control L on your terminal, so that you can clear your screen.
Control is not okay. I don't know how.
Control N. Voila, good. So we do the SCP up. Type the command, the up command to no. Yes, no. The up button so that I can see the command. Yes. Add 2 points at the end of Amazon. 2 points. 2 points. Point.
2 point?
Yes, point. 2 point. No.
No.
Anh thêm cái 2 chấm
2 point.
2 chấm xong một chấm.
2 chấm.
Point. Yes. Enter.
Enter.
Type the enter button. You see.
Okay. Okay. It's good.
Now you can do SSH on the server, and you will have the index one PHP file.
Yeah. Okay, not okay. Moving. Index. And then after moving, set mode. It seems it's okay. Oh.
Okay. So what we will do is that for the rest is we'll continue the class tomorrow. So tomorrow we are going to finish with this and start another topic.
Okay.
So tomorrow you will connect using the same information I provided to you today. Same credential, everything. So nothing will be stopped.
Apache is not working.
My
Apache is not working.
Your Apache is not working.
Yes.
Okay. If someone has a problem, you can share your screen for now. Let me solve it before tomorrow.
Okay. Tomorrow, okay.
Okay, let's share the screen. Where is the share screen button? Yeah. Okay, so here is my instance, and
so did you install Apache?
yes, apt-get update and apt-get install and apt restart. Oh, I mean the systemctl restart.
Okay, so no, move to where is the virtual machine? Okay, copy. Yes, copy, open, copy that. Move to a new browser and paste.
New browser?
Yeah, paste. No, new tab on the browser. Paste. Paste. Okay.
I already paste.
Enter. Go on.
Yes.
Move back to Amazon Windows. Tap on security. Select security. Yes. School. The inbound is good. The outbound is good. Are you able to connect to your virtual machine using SSH?
Yes, SSH is still working.
I think
move back to.
Wait. How do you escape from the sudo bash?
Exit. You just type exit.
Here.
Good.
Okay. Here's my SSH, and it's the same as this address.
So why is your you have to start your Apache server. So do the service. Do type it.
I think you.
Okay, I will access that back first.
No. You are already okay. Go on.
SSH,
You're already in the virtual machine. It's good. You are in the virtual machine. Yes.
Yes, but I just. Oh yes, I'm still in the virtual machine. Okay.
Yes. Sudo bash.
Sudo bash.
Okay. Start the Apache 2 service. So system control, system CTL. No, one word. Yes. Apache start Apache 2.
This one?
Yes. Now try it again on the browser.
Teacher.
Try it again. It's not working.
Yes.
Move back to the console of the virtual machine. Try to see if there's any process Apache 2 running. Use the ps command. PS.
Yes, and then grep.
Yes. Add AUX after the PS.
PS and then
AUX option. Yes.
Yes.
No. Yes. Yes. Gone.
Okay.
Apache is running. So why is the problem? Refresh. Refresh your virtual machine. Refresh the window.
Refresh
the
virtual machine.
The tab. Refresh the tab. Move back to your instance to Amazon console.
Yeah.
What is happening?
Rồi.
Yeah.
Anh bảo cho anh biết lỗi này.
Lỗi gì cơ?
Cái em đang gặp ấy.
Làm sao?
Em chọn Atlas IP cái phần trong Network Security ấy.
Network Security chỗ nào?
Ở bên tab đấy tab bên cái thanh tab chỗ gần Security Group ấy.
Security Group, Elastic IP à?
Yes.
No, you don't need to go into that.
I have the same problem, but I follow it. Em cứ đi, em chọn locate elastic. Yes. Em allow đi, không cần chọn gì đâu.
Rồi name là đâu rồi?
Em kéo cho khung cửa sổ nó dài ra ấy, nó đang bị yếu.
Cái này hay là cái nào ạ?
Cái này đấy em ấn nút action đi, action lên.
Đây.
Action. Không action cái tab bên chỗ allocate đấy. Rồi cái ở đây. Chọn
Instance.
Em chọn cái máy của em đi, instant ấy, instant không cần tích đấy, chọn máy của em. Rồi.
Private IP address không cần.
Không cần. Associate.
Này. Hay là không?
Cần. Associate.
Normally you don't need to do this.
Rồi em mở cái IP lên xem. Đây có cái 3.4 chấm đấy, 3.1 đây đấy. Không. Đây đúng rồi. Đây.
Xong rồi chọn cái nào? Đây.
Không, em copy cái IP đấy lên địa chỉ.
Copy cái IP này lên địa chỉ ạ?
Đúng rồi.
What?
Normally you don't need to do this.
Yes, I don't know. This.
So if I want, thế nếu muốn vào bằng web kiểu HTTPS bình thường thì có gì ạ?
Normally
we don't need to do this.
Yes, teacher, I don't know why.
What is happening?
So they have different IP, so I have to use this IP instead of this IP.
No, it's just that I have the feeling that I have the feeling that you have to associate a public address, IP address, and it's not normal. It's not really normal.
Yes, and these two addresses are different, so I don't know if it works. the IP address is the same, but the IP
Yes,
DNS is different.
It seems like the DNS is not working well on your virtual machine, but
Yes, but
the
the
IP is
address
working.
is
So
what? How? They are the same address.
no, it's not the same.
3.140, 32.167.
Okay, Bob. We
Can
will
you
continue tomorrow. We will
okay.
continue tomorrow. We will continue tomorrow. Okay. For the others, see you tomorrow, same time.
Yes.
Okay.
Okay. Bye bye.
Okay. See you
Bye,
tomorrow.
teacher.
Bye teacher. Bạn chạy rồi.
Okay, bye teacher.
Okay. Goodbye.
Yes. What? Do you like dessert? Yes, please. What is that? Tiramisu ice cream.